Sublakshmi madam, your voice is breaking, please.
Ashik sir, shall I start?
One second.
Yes.
Ma'am, now can start, ma'am.
Okay, sir. A very good morning to all dignitaries and participants. On this pleasant and auspicious Thursday, on behalf of Sairam Institutions and Civil Engineering Department, I welcome you all for the fourth day of 1 week faculty development program on recent trends in civil engineering, Enviro Contact, from 13th December 2021 to 18th December 2021. On this special occasion, now I welcome our dynamic HOD, Dr. S. Bhavati Perumal sir, Civil Engineering Department, to welcome our chief guest and participants. Please, sir.
Sublakshmi.
Sir. Sir. Ashik sir, நான் பேசுறது கேக்குதுல?
கேக்குது மேம்.
சரோட நெட்வொர்க் இஷ்யூவா இருக்கா?
Ashik sir.
Sir, your voice is not audible, sir. It is disturbed. Sir.
Madam, basic time. Thank you, Sublakshmi. Good morning
Yes,
to
sir. Welcome, sir.
all the participants, Dr. Sellagifta madam, and other dignitaries. Topic, Dr. Sellagifta madam.
Sir, excuse me, sir. Your voice is not audible, sir. Sir, your
Fiber
voice...
concrete is
sir,
very important aspect.
Sir, your voice is not audible, sir. Please, sir. Now I welcome my faculty friend, a senior most faculty in our department, Ms. R. Pamela, to give introductory address about our chief guest, Dr. Sellagifta ma'am. Please, ma'am.
A very pleasant morning to one and all gathered here. Am I audible, ma'am? Am I audible? Oh, a very pleasant morning to one and all gathered here. Today we have amidst us an eminent personality, Dr. C. Sellagifta. And Madam has obtained her UG Civil Engineering degree from Manoanmaniyam Sundranar University, and she has obtained her master's degree from Madurai Kamaraj, and she has obtained her greatest that is degree of PhD from Anna University. And Madam has started her career as a quality working engineer for Tirunelveli Spun Pipes Limited. And after that, Madam has started her teaching experience from June 2004 onwards, and till now, even more than 1.5 decades, Madam has heading many positions in teaching, and she has taught most of the subjects from that is design of structures, steel structures, and many subjects she has started. And with this introduction, let me welcome Madam to give her a valuable talk to the fraternity. Thank you, ma'am.
Thank you, Pamela, ma'am. Now it's the platform for you, ma'am. I now welcome Dr. Sellagifta, ma'am.
Sublakshmi, I am audible now. Sublakshmi,
Yes.
madam, I am audible.
Yes, sir. Yes, sir.
My voice is very clear.
Yes, sir. Yes, sir. Yes.
Good morning, ma'am.
Welcome Chellagipta madam, the time when I introduced Chellagipta madam, I have some network issues.
No problem, sir.
Madam is having a very good knowledge about RCC, that is reinforced cement concrete, especially in the field of fiber reinforced concrete. I have been associated with the madam for the last many years. I am proud to say that I am the doctoral committee member of her research activities. I noticed in all the stages, madam contributed her hard work for producing towards fiber reinforced concrete. Madam undergone the research work in MEFCO Slang Engineering College. I wondered by seeing her hard work in different levels. Really, a research scholar should be like this. I appreciated in many occasions. Today, Sairam Engineering College is proud to welcome Dr. Chellagipta madam to take part in this FDP as a speaker. And especially the Department of Civil Engineering is so honored. Madam is right now working as the professor in Civil Department, National Engineering College, Koilpatti. With this introduction, once again, I welcome Dr. Chellagipta madam to share your valuable thoughts to the young community of the faculty members who can take over the messages to their faculties, their students. Welcome you, madam. Please, madam.
Good morning, sir. Am I audible? Ma'am, am I audible?
Yes, madam. Yes, madam. You are audible.
Thank you, sir, for your nice introduction and welcoming me. I'm also really grateful to you as a doctoral student. You have guided me so many things during my doctoral committee meeting. And I'm happy to be a part of this online FDP program. And also, I am happy to know that Sairam Engineering College is daily conducting one webinar or some industry interactions, which is really useful for the present students as well as our faculty fraternity. So it's a very good effort, and I really congratulate all the faculties who are taking so many efforts in bringing out this type of programs. So I think I can move on to my presentation. Ma'am, Subhama, my screen is visible?
Yes, ma'am.
So my topic is toughness characterization of hybrid fiber reinforced
Yes,
concrete.
madam. Screen is visible. Screen is visible, madam.
Oh, okay, sir. Okay, sir. So for the next 45 to 50 minutes, I will engage with the presentation regarding the toughness characterization of hybrid fiber reinforced concrete. Actually, my research area of interest is only in fiber reinforced concrete, and I particularly focused on hybrid fiber reinforced concrete toughness.
From beginning the screen top left corner from beginning
Ma'am, screen visible irukka?
Screen visible irukku. Left corner from beginning irukla ma'am present la.
It's a beginning slide only.
அப்படியே ma'am. இல்ல present screen கொடுங்க ma'am. அந்த from beginning irukla அத click பண்ணுங்க ma'am. Left or from current slide ன்னு கொடுங்க. நீங்க ஷேர் பண்ணிட்டு screen share பண்ணிட்டு okay now it is yes.
Okay, so my topic for the topic of presentation is toughness characterization of hybrid fiber reinforced concrete. So this is my research topic. And my presentation will cover the introduction about the FRC and the special characteristics of fiber reinforced concrete and applications. I just want to quote some applications of FRC. And I focus mainly on the hybrid FRC during my investigation. So I would like to discuss about that. And in hybrid FRC, the toughness characteristics, measurement of toughness characteristics and methods, testing methods, and what parameters has been considered for the investigation, all those things will be discussed. And based on the results, we can make some concluding remarks based on this measurements. So fiber reinforced concrete, it is not a recent technology. It is already developed for the past 4 to 5 decades back. So why fibers are added? Because concrete is very low tensile strength and low strain capacity. So that may cause a sudden failure or brittle failure to the structure. So in order to improve that property, in order to change the behavior of the concrete, these discontinuous fibers or discrete fibers are added inside the concrete. So it is added along with the regular material, conventional material like the hydraulic cement, fine aggregate, coarse aggregate, along with the chemical admixture, mineral admixtures. This discontinuous continuous fibers can be added. And this definition is given by ACA committee. It's a concrete made with hydraulic cement containing fine and coarse aggregates along with the discontinuous fibers. So one special thing about this fiber reinforced concrete is fiber is distributed to the entire composite. Suppose we want to improve the tensile strength by means of our conventional reinforcement bar, these bars will be located only on the specified locations. So it will improve the tensile strength only up to the peak compressive, peak tensile strength, etc. So if the fiber, but whereas in fiber reinforced concrete, the fibers is distributed throughout the cement matrix, and the fiber spacing is also very closer. So it will improve the overall behavior of the cement composites. So this is what fiber actually do. It will not going to improve any strength. It is just going to bridge across the cracks, and it is going to improve the cause stress transfer and increasing the tensile strength. So the main mechanism for adding the fiber is only the crack bridging. It is not only bridging the crack, sometimes it is delaying the crack control, delaying the formation of the crack. It will take large amount of tensile strains and rupture, and especially it is providing more resistance during the impact and fatigue loading. And some fibers, microfibers, which are smaller in size, are particularly used to control the used in the place where we want to reduce the shrinkage cracking. So fiber reinforcement, it's mainly gives the concrete to absorb more energy during the failure. So far our code has not addressed the energy absorption mechanism, but in future it may be expected, and that time this research results may be incorporated. This type of research results may be incorporated in the codal provisions to address that particular aspect. So far our code does discuss only about the strength concept. In future, when we are doing the performance based design, all these toughness characteristics may be taken into account for the design purpose. So I can say the fiber dosage, it is very small. We can add up to 1%. Beyond 1%, it's very, very difficult to produce. It needs some special production techniques and equipments. So up to 1%, we can easily do all these things. There won't be any workability problem. So this is a main point we have to notice. And fibers, some people will add some fibers, and they used to produce some results. This strength has been improved, compressive strength has been improved, like that. But totally it is wrong. Fibers are not added to improve the compressive strength, right? It is used or tensile strength. It is used only for improving the toughening mechanism. It is used only for improving the energy absorption capacity under various loading. So one thing I want to clearly define, that fibers are not should be added to improve the strength, the compressive strength or tensile strength of the concrete. It is added only to limit the cracking and to avoid the brittle failure of the structure. So there are so many types of fibers available. These are all the points already we know. These fibers are commercially available. Metallic fibers like steel, stainless steel, amorphous steel, and some polymeric fibers like polypropylene, nylon, polyester, carbon, etc. And mineral fibers, glass and basalt are popular. And nowadays, naturally occurring fibers like sisal, cellulose, jute, coconut is also available. These fibers are not one and the same. They surely differ in their properties. Only based on these properties, their constitutive response, whenever it is included in the concrete, will be getting altered. So these are the properties taken from Bentur and Mendes textbook, so that we can see different types of fibers that is normally used in making the cement concrete composites. Steel fiber, glass fiber, asbestos, polypropylene, carbon, nylon, cellulose, and sisal, polyethylene, etc. So among this, I work with the steel fiber and glass fiber, polypropylene, and then sisal fiber. And in addition to that, recently I worked with the Juliflora fibers, natural fibers, and metallized plastic waste fibers, and then keratin fiber reinforced concrete, sisal fiber reinforced concrete. So easily we can work on this fiber reinforced concrete, incorporating this type of fibers. This modulus of elasticity and specific gravity, everything is very important. All these factors governs the constitutive response of the fibers when it is used in the concrete. So this fiber reinforced concrete for the past 4 decades, it was being developed. Still now it is in the area of development. Even though there are around 10,000 literatures has been published in this area, at the same time, many practical application has also implemented globally and even in our country also. I will just quote because many people will think how this research will come to and how this research will come to the practical point of view. So to increase that hope, to provide some promising, to make it as a FRC as a promising material, we should say some practical application. I think it's better to project some practical application where it is used. So steel fiber reinforced concrete, it is a popular fiber, and in most of the literatures have dealt only with the steel fiber reinforced concrete, and it is used in it is used for some shotcrete technique. It is used in the shotcrete technique because it is providing sufficient resistance against shrinkage, cracking, and impact and local. It can take all impact loads and compressive loads in floors and pavements. So these type of slabs has been precast segments has been used with the incorporation of steel fibers. But even though we are using it as a precast, using it for precast application, some difficulty is there in bringing this concept to the structural design. That is mainly because of the lack of standards available, and still it is in research point of view and needs more material characterization. And testing method is also differ from one forum to forum. That is, Rylam will say one testing method, and Japanese Concrete Institute the same testing method parameters will be measured in different technique by Japanese Concrete Institute, and ACA will recommend some other testing technique. So there are so many testing methods available, so we don't get a good idea which has to be followed, which one can be properly implemented. That type of confusion is still existing in the measurement of properties for the FRC. Next application is SFRC panels. It is used in Germany. So two SFRC panels are connected by means of the lattice girder, and inside the lattice girder simply the plain concrete is filled inside, and you can see this entire structure is built with this type of precast panels made with SFRC. Since the gap is filled with plain RCC, it can be used in the site, and it can be implemented at the site at a very high casting rate. And third application you can see is the precast pipes with the inclusion of fiber reinforced concrete. It is also very easy. The inside layer is made up of FRC, then steel layer is provided, then it is covered with the concrete layer. So here the SFRC is playing a vital role in controlling the shrinkage cracking, which is most expected inside this cement lining, which is provided as an inside layer. And in this photograph, you can see the structural arches that is built in UK. This type of U-shaped arches has been placed in between the king post wall to form these retaining walls. And this FRC shell structure, I have displayed in my welcome slide. This figure you might have seen. Actually, this is a FRC structure, and the shell thickness is only 5 centimeter, and it is easy. It's called white fiber reinforced concrete. It has got sufficient flexural strength and toughness. The thickness is, you just imagine, the thickness is only 5 centimeter. And FRC tunnel lining segments, this also find wide applications in the construction industry. Barcelona, Spain, this entire tunneling has been constructed with the SFRC for a tunnel depth of 0.9 meter, because these are the precast segments. Why we are using this tunnel precast segments for tunnel lining is there may be a problem of chipping and local crushing when the trains are moving. So to avoid this type of failure and to improve the crack resistance at the early ages, this type of SFRC has been used as a tunnel lining material. And there will be a lot of compressive stress maybe induced because of the uneven contact between the segments. So for this purpose, the steel fiber reinforced concrete tunnel linings has been used. And not only worldwide, we can find some examples in our place also. In Chennai, in IITM, they have provided a road which is marching towards the dining hall at IIT Madras. This entire pavement is made up of SFRC with the incorporation of steel fibers, and 30% fly ash has been added. and 25 kg by meter cube, that is 0.25, around 0.25, 0.25% of volume fraction of steel fibers has been added, and this is a concrete topping that is provided, it is made with SFRC steel fiber reinforced concrete, and it is available at IIT Madras. The grade of concrete is M35. It can be adopted for any type of grading. And the purpose is it is going to reduce the settlement, right? Those problems can be avoided. And this is a terminal yard located at Bangalore. So the industrial floor slabs has been constructed with the Dramix steel fiber. 80 by 60 is nothing but the aspect ratio. The length of the fiber is ranging from 80 to 60, and it is concrete grade adopted is M40. So these are some examples, and metro tunnel, Chennai metro tunnel lining process has been done with the SFRC segments, and ramp at Chennai airport. So they made some SFRC steel, SFRC flooring for a ramp to carry the luggage ducks and trolleys. And this is a boundary wall cast at Navy Mumbai using steel fibers, and stormwater drains. So most of the things we can see only the precast segments. And next, so these are some examples for the applications. So now we can get a hope this metal can be used for practical applications. And when you're dealing with this toughness characterization, you should know the two things, that is, what is the fiber matrix interaction? Because fibers bridging across the cracks, it will transfer the stress through the cracks, and it will transfer from one point to the other point. So the cracked matrix, whenever we can see the left figure, one element is subjected to tensile stress, and crack has been formed, and the fiber is bridging across the crack. So these fibers are essential in transferring the stress from one point to the other point. And due to the transformation, sometimes the fiber pull out may occur. But if the fiber is not able to withstand that stress, the failure may takes place in two ways, by two mechanisms, either by a fiber pull-out mechanism or fiber rupture mechanism. So during my experimental investigation, I observed all the specimens has been undergone fiber pull-out mechanism, because fiber rupture can occur only at the high tensile stresses. So we are not going to apply 1600, because fiber's tensile strength may be varying from 1600, 1700 MPa. We are not going to apply that much stress to the concrete. So I observed most of this specimen has failed only because of the fiber pullout. This fiber rupture is rarely occurring when the bond strength is very high, when the embedment length is large, and when fiber's tensile strength is low. But the third point is not possible. But if it is the condition, then the fiber rupture may occur. So this is one point I want to mention. And next, fiber matrix interaction is purely based on the fiber content. There are so many factors governing the behavior of the FRC, but among that, this fiber content, which I have taken it as a main parameter for my investigation. Increasing the fiber content will totally alter the behavior of the concrete. So in the first diagram, you can see it is for zero fiber concrete. Once it reaches the peak stress, there is a sudden drop. There won't be any possibility of taking the stress. And second case is strain softening case. So you can see once it reaches the fiber, that is peak stress, after that the strain is increasing, but there won't be any increase in stress. It is decreasing. This second curve is called strain softening, and third one is called high performance FRC. So even after this point, post peaking point, post peak point, you can see the stresses keep on increasing, and after that it started decreasing. So this is called strain hardening. This is normal conventional concrete. This is FRC. This is hybrid FRC. So only with the increase in fiber content, we can alter the behavior. This is 0%. This is recommended up to 1% or 1 to 3%. We can expect this type of softening behavior, and up to 5% we can expect strain hardening behavior. So increasing the fiber content will alter the behavior. So this is a point I mentioned. So low volume fraction, only single cracks may occur, that is strain softening. High volume fraction, more than 5%, multiple cracks occur, that's strain hardening. So this is a strain softening and strain hardening diagram. So in the first diagram, even you can see the x-axis is not going to be same in both the diagrams. Here the deformation versus strain. Here the strain versus deformation versus stress. Here the strain versus stress. So in the first diagram, you can see three parts. It is first it is moving in an ascending manner and reaches the peak stress. And at this for this type of conventional FRC, you can see only one crack has been formed, and this one crack, that's called single crack localization. So this crack will gets open, and it will not take any stress. So normally you can see the stress is also lower than the peak stress. After that, the fiber bridging across that one crack will fail by either pull out or by rupture process, and concrete will offer some resistance, but it is very negligible. So you can see after this crack localization, it will not take any stress. It is decreasing and finally reaching the negligible value. So this curve is very important because we are going to take the energy absorbing mechanism only based on the area below the diagram. This is strain softening. Strain softening is consists of three parts. First one, reaching the peak, then attaining the localization, then the stress decreases with the increase in strain. Three parts. This is called strain softening. Then strain hardening is totally different. After the first segment is very similar. After reaching the peak stress, multiple crack localization takes place. There only one crack is involved, but we cannot take that one crack deformation as a beam deformation, beam strain value or beam deformation. That actually it is only for the strength point of view we can take like this. But if you want to discuss the energy absorption mechanism, you can see multiple crack localization takes place. So this multiple crack bridging across the fibers bridging across the multiple cracks will improve the tensile strength. So the tensile strength of the composite is further increased and it will take load. After that, if any one single fiber may attain the localization, that is again the crack gets widened, means other cracks getting closed, and again the same softening point is repeated. So in strain hardening, it is increasing. After that, multi-cracking takes place. So that will improve the tensile strength of the composite. So after that is after increment in the stress, maybe if there is any opening in the one bigger crack, that will become the single localized crack. So that will get widened while other cracks may get closer. So after that, it will not take any stress, and it will reach the zero value. So this area below this diagram is quite larger. So it will give more energy absorbing capacity. Here you can see the area is much lower. So the energy absorbing mechanism may be absorbing capacity may be lower. So we understood from this theory, we understood that concrete cracking is not going to take place at a time. It is a gradual and it is multi-scale, and the crack growth, there is a possibility of controlling the crack. That one idea has been evolved based on the previous photographs. Concrete cracking is taking place in a gradual and multi-scale level. So instead of adding one fiber, because each fiber is playing its own role, so instead of adding one fiber, I thought of adding different fibers in the same composite, and that's called hybrid fiber reinforced concrete. Not only fiber materials differ, the sizes of the fiber is also differ, and the volume fraction and modulus of elasticity, everything has been combined and to produce a new composite called steel polyester hybrid fiber reinforced concrete. Why I have chosen this steel fiber? Steel fiber is popular and it is available everywhere. That time it has been used for many applications, and polyester fiber, that time it's getting popular in India. So I thought of adding the polyester fiber, and I want to explore the properties made with the combination of steel and polyester through this research. So the concept of hybridization, that is also a matured science nowadays. We are adding two or more fibers in the same composite, and resulting mix is often known as hybrid FRC. That is, one fiber will complement the usage of other fiber. They will effectively utilize the potential property of the other fiber, making the entire composite as an effective one. So this concept is a very good idea, and we can do a lot of we can explore a lot of properties of this hybrid FRC still. And synergy mechanism can be made based on the fiber constitutive response, fiber dimension, one fiber may be fiber constitutive response is one fiber may be suitable for improving the hardened property, the other may be useful for improving the low modulus, can be useful for improving the fresh properties. So like that, we can make some combinations by means of constitutive response, fiber dimension, short fiber, long fiber, and fiber function. Some fiber is having very low stiffness, some fiber may have high stiffness. So like that, we made some combinations. And always characterization of any new composite is very essential, because then only we can able to identify the material. We have to we can quantify the characterization, we can qualify the characterization, and we can check whether the material is robust enough to withstand the specific purpose. So always we need the proper characterization of any materials. Especially in FRC, we always concentrate on workability, shrinkage, crack resistance. So always the quantitative information is also made only on this property, crack resistance, mechanical properties, toughening mechanisms. So these parameters are further useful for the design analysis. No need to concentrate on other properties like durability. Those properties can be dealt later, but primary measurement is only for measurement should be focused only on the workability, shrinkage, and crack resistance and toughening mechanisms. So I have chosen 45 MPa grade of concrete, and mixed design is as usual, as per our conventional method I have adopted. And cement has been added up to 395 kg, and fly ash has been replaced with 15%, silica fume 7%, and combined gradation has been done with this two size of aggregate 20 mm and 12 mm, and high range water reducing PC based admixture has been used. So this is very essential, and this is also, it's a new generation chemical admixture that is used for reducing the water requirements for the production of some cement composite. High range what polycarboxylic ether based admixture has been used, and this table shows the fibers that is used in the test: steel fiber and polyester fiber. I have adopted this hooked end mechanical fibers for us. It's a very good geometry, providing proper anchorage to the composite during the time of crack resistance. And these properties are essential when we are when you're fixing the volume fractions of the fibers. So these two fibers has been added, and these are the series of mix I have adopted. I have adopted 4 series of concrete mixes: control and steel fiber, polyester fiber reinforced concrete, and hybrid fiber reinforced concrete. And these are the volume fraction. There is no strict rules and laws to choose this. We can randomly adopt to, and I just want to understand the behavior, so I can able to adopt this fractions randomly. I have referred some literatures and adopted this type of volume fractions for the production of concrete samples. And for the toughness characteristics, I just added some more series because this is my main area of research. And compulsory we have to adopt this type of pan mixture for production of FRC, because we are just adding the fiber, something like adding the sand. So it should be properly distributed. The mixture should be a homogeneous mixture. So in order to make the composite as a homogeneous, the fiber should be properly distributed throughout the mix. And the mixing process should also be done carefully. And you can see, and also table vibration is recommended in the literature, because we cannot adopt any internal vibration like compaction or needle vibrator, because we cannot place the vibrator inside the FRC. There will be some obstruction. So literature has recommended only the table vibration. And these are the casting sequence of specimens. Specimens has been casted carefully, and it is immersed water curing for 28 days. After 28 days, it is taken for testing. So these are the details of the test specimen. These are the normal specimens. Compressive strength has been checked, spill tensile strength, the modulus of rupture, drop weight impact test. In the serial number 4, 5, 6 are dealt with the energy absorption mechanisms. Energy absorption under split tension has been studied with the cylinders of 150 mm diameter, 300 mm height. And drop weight impact test was conducted in a disc specimen 150 mm diameter, 64 mm thick. The specimen sizes are taken from the ACI 544R recommendations. And energy absorption study under uniaxial compression has been done in cylinders of 100 by 200 mm height, and other 3 are normal specimens. And workability is also very essential parameter in FRC development. Normal slump cone test is recommended, and you can see that it is ranging only between 90 to 190 to 90. So the incorporation of the fibers will affect the workability, but nowadays we are adding PC based admixtures, so it is not at all a big problem. And also I have added silica fume as well as supplementary cementation material like fly ash. Fly ash, the nature of fly ash is spherical in nature. So the particle spherical in nature will always give some that will always improve the workability. So particles, if they are very spherical in nature, less frictional resistance, that will obviously improve the workability properties. And silica fume is also finely dispersed particles. So all these things helps to improve the slump properties of the concrete. And test series has been as per the standard procedures mentioned in the IS codal provisions. And for each series, 3 specimens has been tested, and for a compressive strength test has been conducted as per IS 516, and split tensile strength has been conducted in the cylinder at the age of 28 days as per 58116 specifications, and measured the split tensile strength. And also every time the failure pattern is observed, especially in case of FRC, the failure pattern has to be observed. And also the modulus of rupture has been tested in 100 mm by 100 mm, 500 mm long specimen as per 516 procedure. And these are the test results, and you can see the test results of the 4 series. And please observe the last column of the table. So from this we can understand the effectiveness of adding the fiber. So control concrete gives a reference value, and steel fiber, in steel fiber series you can see the range is increasing. Increment is only from 10 to 13%. And in polyester fiber it is a little bit lower. It just starts from, sometimes it is only 3% improvement. And in hybrid fiber reinforced concrete also you can see the maximum improvement is only up to 15%. So what we can conclude is fibers will improve the compressive strength, though in single FRC or hybrid FRC the improvement is very, very marginal, and it is observed only up to 15%. The confinement of the fiber, the tensioning stiffening effects of the fiber will improve the compressive strength. And also I have added silica fume 5%, so that will also enhance the bond property between the fiber matrix and the concrete. That will provide a dense microstructure always. So all these parameters has influenced the compressive strength, but not very big change is expected, only 15%. So this I have analyzed whether the influence is based on influence of fibers on the single fiber FRC, in steel fiber on compressive strength, and effect of polyester fiber on compressive strength. So all those observation has been made, and you can see the polyester fiber, the compressive strength is lowered, and because of the low stiffness, this is already expected property. But whereas in steel fiber it has been improved because it is having good mechanical anchoraging, and binding across the cracks is also very good. And this diagram is a comparison made based on the hybrid FRC series. And you can see among the 4 series, HF3, which is having the high polyester fiber, has lowest among all the 4 series. So the conclusion is steel fiber either as a single dosage or in a hybrid combination, it is not going to enhance the compressive strength. So this is a conclusion we can make in split tensile strength, but you can see the drastic change in the split tensile strength. The improvement is observed to be 46%, 63%, 80%. But in polyester fiber, it is ranging from 18 to 26. Again, in hybrid fiber reinforced concrete is ranging from 66 to 72. So you can see a very good improvement in case of split tensile strength. So all the specimens has been shown higher split tensile strength than the control concrete. And again, the analysis were made with the help of values obtained in the single fiber concrete, volume fraction versus split tensile strength. So you can see the enhancement of steel fiber is ranging from 46% to 80%. It's a very, very favorable property. And one of the useful property that is further, it can be explored for the performance based design. And higher stiffness, which is bridging across the steel fibers, that is a main reason. It is bridging across the cracks, increases the load and enhance the split tensile strength. and most of the failures were pull-out failures. There is no fracture failure. And but when you're looking into the polyester fiber, the improvement is only 18% or 17%, because once the polyester fiber has been added, we observed a lot of entrapment of air inside the concrete, which is totally reducing the strength of the concrete. And this comparison is also made. And next property is flexural strength. But even though my title is about the toughness characterization, I should say, while characterizing the entire composite, I have made some studies related to strength aspects also. Okay, so at this juncture, I want to mention that also. And flexural strength improvement is somewhat lower than the split tensile strength improvement, but it is not big drop. Steel fiber reinforced concrete, the improvement is between 16 to 56. Then polyester, I observed between 13 to 31% improvement with increase in fiber content. And hybrid fiber reinforced content, the improvement is in the range of 36 to 60%. So the percentage of MOR values has been approximately improved 31 to 60%. Among that, HF4 series, which contains more amount of steel fibers and more amount of polyester fibers, shows the highest flexural strength. No MOR value has been decreased with the increase in fiber content. But in previous two strength aspects, somewhat we are changing, we are observing the changes. But in flexural strength, with the increase in fiber content, the flexural strength is also keep on increasing. And we observed the hybrid series is mainly dominated by the metallic fibers, and synthetic fiber behavior is not much pronounced. And this is a comparison made with the single fiber FRC with the modulus of a rupture. And below the neutral axis, the bridge cracking mechanism is well defined, and they delay the crack propagation. They preserve the integrity of the specimen, and fiber failure takes place by the pull-out strength, which indicates a good bond strength between the fibers and the matrix. And again, the synthetic fibers exhibit their weakness because of their low stiffness and high deformation and poor adhesion properties. So this is again the comparison made among the hybrid fiber series, and the comparison made with the steel fiber and combinations. So this HF1, HF2, HF3 is generated with the MS.5 with the combination of polyester. This HF4 is made with the combination of MS.5 and other polyester. So the comparison is made with single FRC and hybrid FRC here also. So it shows high modulus of rupture, and again the polyester fiber property is not decisive since they produced very low flexural strength. Next, I just focus on the energy absorbing capacity. This is one of the special property of the fiber reinforced concrete and hybrid fiber reinforced concrete. The toughness property is very much essential because it enhances the crack resistance. FRC fibers enhance the crack resistance and energy absorption capacity. The toughening can be measured in any ways: compression, tension, shear, flexure. So if the sufficient testing facilities are available, we can check all the toughening mechanisms. Based on the availability of the equipment, I just focused only on the compression toughening under compressive load, and tension, split tension toughening mechanism. So what is energy absorption capacity? This is the area below the load displacement curve, or I can say stress displacement curve. Whatever the appropriate. If it is a strain softening, we can take stress versus deflection. If it is a strain hardening stage, we can take stress versus strain. And here the sharp post peak drop is avoided in the energy absorption capacity. You can see the long plateau after the post peak has been reached, and post peak ductility increases with the increase in dosage and effectiveness of the fibers. So normally we are taking the area below this curve is taken as the toughening effect of fibers in concrete. And to measure the toughening effect, I have taken three mechanisms. One is impact resistance. Second one, split tension under this toughening mechanism has been measured. Third, under pure axial compression, the toughening mechanism has been measured. So impact resistance, I conducted a drop weight impact test called Shredder impact test in the disc specimens of 150 mm diameter and 62.5 mm thickness. It is conducted as per 544 at the age of 28 days curing. This is very simple test. We have to make some disc specimen which is placed under this drop weight hammer, and this inside this plunger this hammer is inserted, and now we have to give number of blows. The height of drop is measured to be 457 mm, and you can see the specimens were cut by means of the concrete cutting machine to make this disc specimens. Initially I made the cylinder, then it is cut into cylinder, they cut into disc to do this shredder impact test. So now it is placed in between these three bottom screws, and it is provided with some damping effect in order to avoid the movement. And then it is a hammer blow is allowed to allowed on this disc specimen, and the number of blows is counted to cause the first crack and ultimate failure. So this is a observation we have to take. Based on the blows, we can convert it to the energy absorbed by the specimens. Ultimate failure and first crack observations, and failure pattern is also noted. And this table shows the impact resistance, energy absorption capacity under impact load. First crack under impact load, this column shows the energy absorbed in the first crack, energy absorbed during the next column shows the ultimate failure. So the control concrete, you just see it is only 82. Steel fiber reinforced concrete, the energy absorbed joules in joules, it is ranging from 164 to 596. MS 0.75 volume fraction has reached 596 joules energy absorption capacity. And again, the polyester fibers has a very it has shown very poor resistance in case of impact. So the energy absorbed is only 41.13, whereas the steel fibers has absorbed impact energy up to 596. On hybrid fiber reinforced concrete at first crack, the energy absorption is again extended to higher value. It is ranging from 164 to it went up to 514. This is for first crack. Whereas in ultimate failure, the improvement was very good. Control concrete carries 123, impact resistance in joules is 123. Then steel fiber, it is always in the range of thousands. You just see the polyester fibers is only 80 to 16. But again, the hybrid fiber reinforced composites shown a highest improvement in the impact strength. It goes up to 7,650. So this picture clearly shows the effect of single fiber and hybrid fibers in the energy absorption mechanism under impact. So this is a first crack diagram. All these orange bars, orange color bars shows the highest energy absorption capacity made by the HF hybrid fiber series. And this green, it is almost negligible. It is all polyester fibers series. And yellow is single steel fiber series. So this diagram clearly dictates the amount of energy absorbed during the impact load. So I can conclude it as a high fracture energy. The energy has been increased 15 times. It's because of the good bonding anchorage. And hybrid FRC, the improvement is up to 62 times. And while observing the failure pattern, the punching shear failure is observed. It is observed on the disc specimens. And steel fibers provide better impact resistance to control the local failure. And in addition to that, silica film also necessitates the effective dispersion of fibers throughout the composite and improves the impact resistance. And hybridization, the no clear trend is observed with respect to the fiber content. We cannot, with these values, I cannot able to conclude because the values are changing very randomly. So it is very difficult to make a clear conclusion based on that impact resistance in hybrid FRC with respect to the fiber content. And excess polyester fiber content decreases the impact resistance. And highest energy observed in HF4 series shows the ductile response of the members. Impact resistance has been increased several times. So the same comparison has been made with the graph. And next, the energy absorption toughening and toughness characterization has been measured under split tension. I have conducted Brazilian test as per the literature. This testing procedure is followed as per the literature given in the slide. And it is conducted in the normal cylinder, and this type of special attachment has been made, and we used to measure the deformation. I used the dial gauges of 0.002 mm sensitivity. So from the load deflection curve, from the load versus deformation observation, I just measured the initial cracking stress and I plotted the load deformation curve to measure the energy absorption capacity. And this is what the arrangement of the split tension toughening test. I just attached this dial gauge with the steel cylinder by means of this L-shape steel plate and with proper adhesives. And again, the load is applied in an incremental manner and the corresponding deformation is measured. This is called load control measurement, but it is better to go strain control measurements in FRC. The displacement has to be controlled and the corresponding load has to be measured. This is a proper way to measure the FRC measurements. So I just followed the strain control measurements in my experimental observation. So you can see the initial cracking stress in split tension under split tension loading condition. The last four rows, obviously it is hybrid fiber series. So the split tensile stresses has been in the range of 2.4 to 3.82. Whereas the control concrete 1.3 and steel fiber it is 2.1. And in polyester fiber, it is in the range of 1.2 to 1.7. And we plotted some load deflection behavior for various series. For example, the area below the HF1 series for the 3 specimens is reported as 145.63. So normally we have to cast more specimens when we are doing this type of experimental investigation, because we have to do lot of trial procedures, then only we can take the final concluding values. Just by placing the specimen, immediately taking the results is surely impossible in case of FRC or hybrid FRC measurements, because each and every deflection will alter the behavior of the concrete. So we have to do, I used to cast 8 to 10 specimens for each series. Out of that, some specimens may behave till the end of the strain softening or strain hardening. Some may immediately fail due to some mechanical testing equipments. That is also one parameter. So we have to actually cast more specimens when you're making trials. So HF1, the energy absorption is 145. And here you can see the comparison made with the HF1, because it is made with a combination of 0.5 polyester, 0.5 steel and 1%. So the energy is improved 120 to 145, and MP1 polyester 89 to 145. So the incorporation of different fibers has improved the energy absorption capacity. So this figure shows the strain softening, strain hardening behavior, not strain softening, strain hardening behavior. And you can see the HF1 series all has shown a very good energy absorption capacity under split tension loading mechanism. And this is pure comparison made with 0.5 to HF1, 0.5 steel to HF2, 0.5 steel to HF3 and control concrete. You just see control concrete, it's abrupt failure. Okay, you can see this rose color curve. Rose color curve indicates abrupt sudden failure that's happened in the control concrete. And energy absorption capacity, the same values which is represented in the diagram is shown in the sketch. And this is a comparison made, and the initial cracking stress improvement has been observed to be in the range of 13 to 69. And in HF1, 2, 3 series, the values has been improved 62, 72 and 26. So all these observations were made with the experimental part. So I can see the initial cracking stress improvement 69% greater. It is provided because of the effective stress redistribution. And we can see the long energy absorption curve is a long plateau. Deformation curve is a long plateau. And I observed a positive interaction between the fibers because they provided the effective crack control mechanism to withstand the load. So these observations, some important observations were made. Concrete without fiber, 0% fiber causes sudden failure, whereas the other series, large amount of deformation takes place and failure is very gradual. And you can see the energy absorption capacity is 18% higher than the single FRC. And initial cracking load is increased because of the steel fibers, and the polyester fibers will can able to withstand some additional loads because it is a low modulus fiber, but it will allow large amount of deformation. Polyester fibers are playing a role in allowing the large amount of deformation. It will not, even after the cracked stage matrix, it will allow the deformation. So the high polyester fiber content, sometimes the negative responses is also observed. And next, energy absorption under uniaxial compression. Normal cylinder is used 100 mm by 200 mm. So with the available testing facility, we have conducted the test. Okay, because if you want to measure some toughening mechanism, each code will specify some sophisticated equipments which is not usually available in many places, because we need servo control equipment. All those equipments are available only at SCRC or LNT and IIT Madras. I came to know only 3 places they are having this type of servo control measurements. So I cannot adopt those testing procedures, other RILAM or JC procedures. I just followed the methods which is available, which is possible, which is feasible by us. So again, the dial gauge has been used and the low deformation behavior is noted and the curve is plotted using the Simpson's rules. I found the energy absorption capacity. For comparison purpose, I have taken the energy absorption capacity up to 0.6 mm deformation. Last time I have taken the energy absorption capacity for split tension up to 0.4 mm. Here it is taken up to 0.6 mm. So again, you can notice in hybrid FRC, the energy absorption capacity is in the range of 196 to 241. And in steel FRC, it is 149 to 205. Control concrete without fiber, just 56. It doesn't absorb any energy. And polyester fiber, even it is improved up to, it is enhanced. It is in the range of 153 to 176. So this is a comparison study with the help of the graph I have shown. And this is a curves we plotted based on the low deformation measurements. And the area below the diagram is measured up to 0.6 mm. It is taken by Simpson's rule. The area below the diagram is reported as the energy absorption capacity in kilonewton mm. And this is a comparison made between the steel polyester fiber series. And among all the hybrid fiber series, C I included just for compression. So nothing changed from the previous specimens. Just C is included. It is for compression testing, uniaxial compression testing. So the C is doesn't make more difference. So MS 0.5, which is added with the polyester fibers. So that the energy absorption capacity, 224, 217.8 polyester, 1% polyester addition shows 196. 2% shows 202, whereas the single steel has shown only 182. So all the 4 series has shown highest improvement in the energy absorption. But one thing I want to mention in experimental part, by adding something in concrete, we cannot expect a big change. People before doing research, they will think like that, but once you involve, then only you come to understand we cannot suddenly change anything. We cannot bring a drastic change in experimental through our experimental. Only a small change can be done, even though it is it is accounted for our future investigation. So this is a CC 56 and it is compared with the other combination CH4, which is made up of 0.5 and 2% polyester. So the comparison is made between 0% fiber and hybrid fiber and hybrid fiber combinations from which it is made up of. So I can see the big changes in this number, energy absorption in joules. So this is some salient points we observed from the diagram, load versus deformation curve. The peak compressive stress was observed up to 46 and post peak deformability. That is a very specific character of this single FRC or hybrid FRC. So you can see the CC concrete, control concrete, there is no post peak, just it reaches the peak, sudden failure has been happened. And MS 0.5 is a steel fiber. So you can see the very good softening characteristics. And MP polyester 2 has also shown strain softening behavior. And also this CH4 series, you can see the strain softening and strain hardening as well as. So polyester fiber have shown a better strain hardening in the post-peak response. And the region prior to the cracking exhibited, that is a normal property. Before the post-peak point, we used to consider it as a elastic brittle behavior. So that is our general theory. And strain softening behavior is observed in CH2 in some series like CH2 and CHF3, F4. And hybridization based on fiber function and based on fiber dimensions, it provides effective crack resistance and enhanced toughness characteristics. So these are some additional points. I have measured only the energy absorption capacity up to 0.6 mm. This is for comparison purpose. Even though the curve is plotted till the end of the failure, for comparison purpose, EA is measured only up to some fixed value. So synergetic effect of different modulus and different size of fibers increases the energy absorption capacity. And after quantitative information, after quantitative characterization, some qualitative characterization is also essential in FRC. And we can see the brittle or catastrophic failure in case of FRC, in case of a plain concrete and brittle, but here it is a ductile mode of failure in case of steel fiber reinforced concrete. And we can stand very boldly near the equipment and we can do the testing when we are doing the FRC. But whereas while testing the control concrete, we used to scare about when the specimen will fail, because it's a sudden explosion. Already it is M45 grade concrete. So the ultimate strength will be 65 MPa, 70 MPa. So when you're doing the testing in FRC, no need to worry because the failure is very gradual and it is only ductile, and no need to worry about the testing methodology. We can do the test in a very safe manner. So you can see the complete failure in case of control concrete. The specimen has been totally split into two. But these 4 specimens, even after testing, the integrity of the specimen is still maintained. Only one single crack has been occurs along the specimens. And the bottom diagram, the bottom line diagram, this is a control concrete. And this 4 specimen has been flexural beam tested after flexure modulus of rupture testing. So still the specimen integrity is maintained, no complete collapse or catastrophic failure. And this is during the time of impact testing, ultimate failure. We made the specimen to undergo ultimate failure. So this type of observation has been made. And this is during the energy absorption test. And this is control concrete. You can see the entire specimen has been split into 2 pieces. And in steel fiber, you can see the stitching of fibers across the cracks. Still, the failure is very slow and gradual, and that it is not a brittle failure. And in the last picture, you can see the hybrid FRC. Even you cannot see where the failure has been occurred. Only one single crack has been passed. So this is a crack which has been occurred in the hybrid FRC specimens. So these are the specimens tested. Even though it is undergone severe loading, we cannot see a big cracked matrix in this pictures. So this is control concrete, total failure under uniaxial compression. Polyester fiber series, that is also, it is poor in withstanding the compressive load, I already mentioned. And this is a steel FRC series. You can see fewer cracks on the surface. So the multiple cracking localization is the very favorable aspect of this FRC and hybrid FRC, because many fibers will crack this, will bridge across these cracks and improve the tensile strength, even though the cracked matrix will undergo large amount of deformation till the complete failure has been occurred. And you can see the tested specimen. It is actually a tested specimen, but no much failure cracks has been observed. So it has got a very good crack arresting mechanism. So the overall conclusion is compressive strength has been improved up to 15% with the combination of 0.5 and 1% polyester. And when in case of split tensile strength, the significant improvement is observed in the range of 63 to 72 for the 0.5 steel and 0.5 polyester combinations. And marginal drop, small drop is also observed from 88 to 80 for 0.75 because of the excess dosage of 1% polyester fiber series. And flexibility has been improved up to 37% with the inclusion of 0.5 steel and 1% polyester, and 60% for 0.75 and 1% polyester. And whenever you're thinking about the impact resistance, it is improved from 4 folds to 60 folds. And in ultimate crack also, it improved from 5.6 folds to 347 times. So all these things only because of all these improvements are only because of the incorporation of hybrid fibers. So failure pattern, so it is proven through the photographs. All the failure pattern has been observed as a ductile failure, and energy absorption capacity toughness has been improved from 26 to 72 in comparison with the polyester fiber, and it is between 10 to 18% when compared with the steel fiber. So when we are comparing this pure steel fiber, the energy absorption capacity improved up to 18. When we compared with the pure polyester, it has been improved up to 72%. In hybrid fiber reinforced, highest energy absorption is exhibited 224 joules with 0.5 steel and 0.5 polyester in combination, and 241 joules when 0.5 steel and 1%. So from all these results, I understood steel fibers dominated the entire energy absorption capacity. And also initial cracking stress has been improved from 13 to 69%, and peak compressive strength under uniaxial compression while measuring the toughening, that is also improved up to 25%. And I didn't present the ANN modeling which I did in the PhD work. Actually, because we cannot do all the experimental procedure, it involves some laborious work. So it's very difficult to make specimen and testing every time. So the practical difficulties involved. So what I did is, after getting the experimental observation, I understood the behavior. I made some ANN modeling at the end of the experimental part. So I have included that point also. And I want to mention the PC based admixture provide effective dispersion of fibers and flowability and stability to the mix. So this PC based admixture is highly recommended, and higher dosage of fibers reduces the improvement because mainly because of the polyester fiber intrusion of air during the mixing process, which is unavoidable. So that causes some decrease in the strength values. And the cost analysis, since it is a special concrete, we are adding some extra material. Normally the cost of this steel polyester fiber is not going to be cheap. It increases the cost by 75%. And enhancement, while considering the extended life period, even though there is a cost improvement, even though the material is very costly, while considering the enhancement in the mechanical properties and extended life service, makes the material as a more promising material for concrete pavements, industrial slabs, overlays, concrete barriers, tunneling segments, etc. So my experimental work is limited to few fiber volume fractions. I consider only one geometry and consider M45 grade of concrete. So future it can be extended for other volume fractions. I have taken only few volume fractions. For other volume fraction, this work can be extended, and aspect ratio of the fibers can be changed. Geometry of the fibers can be changed, and strength of the matrix. So all these factors will govern the properties of the entire composite, so we can change it. And stress strain relationship, I just taken only the load deflection curve and stress strain curve, and we can establish some new empirical equations for this stress strain relationship of steel fiber reinforced. Analytical modeling work can be done, and we can do this fiber reinforced concrete and hybrid fiber reinforced concrete are effective in taking the dynamic loading. So we can apply some monotonic loading and compare it with the cyclic loading. We can measure how many number of cycles it can be repeated, and corrosion point of view, permeability point of view. The cracked matrix can be studied under corrosion permeability point of view, and it can be included in the hybrid FRC composite can be included in the beam column joints to measure the energy absorption capacity. And more mathematical, all these procedures are experimentally done, and more mathematical modeling can be evolved. And my experimental contribution is for the measurement of energy absorption capacity and strength properties. And analytical contribution has developed some equation which gives energy absorption properties of steel, polyester, hybrid fiber, and always we should give some engineering contribution. So based on the energy absorption capacity, if you're referring to the Barton's chart, I can able to recommend what type of thickness of pavement can be adopted for the pavement design and everything. We can refer, for example, energy absorption is greater than 700, it is poor. If it is greater than 500, like that, based on the fiber reinforcement, we can judge the thickness of the shotcrete that can be designed. So these are the publications made out of this work. First 3 are purely based on the experimental work, and after that also I extended my research interest only in fiber reinforced concrete, and recently worked with the Julie Flora fiber reinforced concrete, and published a paper in Taylor and Francis. And further, with the help of students, I worked in metal-based plastic-based fiber reinforced concrete to produce Corpus Index journal and glass fiber reinforced concrete. So repeatedly, I just want to explore only the properties related to the FRC and hybrid FRC. So this is all my presentation, and I thank you very much for giving this opportunity, and I thank the participants for sparing your valuable time and your attention. Thank you.
Thank you, madam. Very informative and wonderful presentations you have made.
Okay, sir.
And last around 1 hour 15 minutes, we could not move from our place. That much inspirations you have made through your presentation. Thank you,
sir.
madam. Thank you a
sir.
lot. Especially you have highlighted about the steel, polyester and hybrid fiber, and how the properties changes, especially to prevent the crack control. That is the aim of your research work. And you have made in-depth
Sir,
research
your voice
studies.
is not audible. Sir,
In-depth
Ma'am,
research.
it's audible, ma'am.
In-depth research
Sir,
you
your
have made.
voice very-
You have made, and this kind of presentations, the research-oriented presentations, will help the younger faculty members when they attend this type of programs. How the experiment to be conducted, how to make the models, how to find the results, accurate results, how to draw the graph. And many of the research scholars, they are not getting any awareness what to do practically. So today, you have taken all the young faculty members, those who are doing the research work, or those who wants to do the research work, to the civil engineering laboratory. And certainly the participants are benefited by projecting your work related to steel, polyester and hybrid fibers.
Thank
Very
you.
wonderful work.
Thank
Very
you, sir.
wonderful work. Very wonderful presentation.
Thank you.
And we all enjoyed a lot. All the participants, no doubt, they got some information about conducting the experiments in the laboratory, conducting the experiments in the research centers, and how to make the result as per the expectation of the journals and everything. Very good presentations, madam. We are so thankful to you. We are honored because of your presence today. Sai Ram family is honored because of your presence.
Thank you, sir.
Thank you.
So participants, if you have any doubts, please raise your hands.
My suggestion to the participants, those who are interested to select the area for the research, madam has highlighted the future scope. That future scope, you can continue this fiber reinforced concrete project by making any models. By making any models, you can continue this work to do much more research in the field of fiber reinforced concrete. That is my suggestions to the younger generations.
Yes, sir. Yes, sir.
Okay. Sir, you can unmute and you can ask your question, sir.
Okay, ma'am. Thank you. Actually, I have a doubt about the ma'am has worked in both steel fibers and natural fibers. So, which fiber will be better in the case of availability and economical point of view? Ma'am, am I able to hear me?
Yes, sir. Yes, sir. Commercially available fibers, that is only based on the application we used to choose the fibers, sir. Suppose if it is a very important structure which has to withstand for high energy absorption capacity, means we have to go for some high modulus fiber, because all these natural fibers are easily available and it is free of cost, means automatically the application is also for a less important structure. The energy absorption capacity may be very lower. So only based on the performance based design, we can go for the fiber applications. We cannot fix this fiber has to be chosen. Depending on the requirement, we can add the volume fraction, we can make the concrete, and we can improve the performance.
Okay, thank you, ma'am. I have one more question. During your presentation, you have said that that durability point of view, we can come later like that, you said, but the thing is that are you about to say that if you in the case of fiber reinforced concrete, the durability will be always high? Actually,
Yes, sir,
what I
the
understood is
crack.
like that only, but I'm not a special person in concrete, so I'm just asking this doubt.
Yes, sir. The fibers are added only for improving the mechanical characteristics of the concrete, but durability properties are also there, only satisfying all this serviceability and load requirements characteristics. Only we can define it as a promising construction material. And also the crack resistance is much higher in the fiber reinforced concrete, so there is no need to worry about the corrosion point of view. But we can do a lot of work in permeability permeability measurements in cracked matrix to understand the durability aspects. Among all properties, the permeability is a major property which is still left out, and we have to do a lot of research in this hybrid FRC made with the state polyester. Permeability properties has to be addressed more. Then that will control the inner, because only based on the property the ingression of moisture will go inside, that will disintegrate the concrete and making further problems. So the permeability aspects and further, if possible, corrosion has to be studied. And still we need to do research, but I concentrated only on the toughening mechanism for the characterization.
Normally, madam, this selection of the fiber depends upon the nature of the work.
Yes, sir. Depending on the application
Yeah,
only.
depending upon the, that is the answer I want to add with you to the participants.
Soon the codal provision is also about to come, sir. They want to concentrate on the toughening concept in the design.
Yes, yes.
And this type of research results will be considered.
For example, natural fibers which are predominantly available. But for example, if you are going for a high strength concrete, then in what type of fiber is applicable, that way we go to select the fiber and we go to do the testing.
Yes, sir. This is only for special structures and special applications.
Thank
but
you.
Since it is available, fiber info for natural fibers, we can do some work and find appropriate application.
Yes, 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 yes. Thank you.
Thank you, ma'am. I have only one more question.
Yes,
please bear with me. You told that you worked in you applied a neural network for your research. So what extent this neural network is giving the better results? I mean, is it 90% that confidence that it is giving?
Yes, sir. We did some sensitivity analysis and I got up to 83% accuracy in my results because every time doing the experiment becomes very tedious for me. So in between fraction, I didn't identify through experimental. The in between fiber volume fraction behavior has been obtained only through the artificial neural network studies. I used NN tool for doing the regression analysis and to obtain the characters. I got the sensitivity, I got the accuracy of results up to 83%. I made some sensitivity analysis that we have to do compulsory.
Okay, thank you, ma'am. Did you use that back propagation network or some other
yes,
network?
Sir, back propagation, Leeuwenberg Mark algorithm has been used, and back propagation technique and regression analysis. This is very popular nowadays in concrete research work, so you can easily learn and we can do a lot of work in that. We can do modeling also.
Thank you, ma'am. And if you don't mind, will you suggest some topics like we can give for BTech students?
Permeability aspect has to be immediately studied, sir, for hybrid FRC. Durability point of view, already we did some experimental work in electrical resistivity, chloride penetration, etc. but the permeability property can be addressed. And nowadays, some other composites are also added in the concrete in FRC, like recycled aggregate. Then what is it? Some geopolymer concrete. So the composites can be modified, and behavior of fibers in that composites can also be studied. But only the fiber properties are going to dominate. But anyway, we have to study the influence of other composites in the incorporation of hybrid fibers. So that also we can do.
Thank you, ma'am. Thank you so much.
Thank you, sir.
Thank you, ma'am. Thank you, ma'am. Participants, any other queries?
Thank you, ma'am.
Before I thank, I congratulate from my heart, ma'am, for your marvelous pieces work. Your presentation shows that how hard you worked, and the volume of work shows your dynamic knowledge on FRC. My heartfelt thanks for the wonderful talk on toughness characterization of hybrid reinforced concrete. With all your permission, I would like to tell about the small history of FRC. The concept of using fibers as reinforcement is not new. Fibers have been used as reinforcement since ancient times. Historically, horsehair was used in mortar and straw in mud bricks. In 1900s, asbestos fibers were used in concrete. In 1950s, the concept of composite materials came into being. The fiber reinforced concrete was one of the topics of interest. Once the health risks associated with asbestos were discovered, there was a need to find a replacement for the substance in concrete and other building material. By the 1960s, steel, glass fibers, and synthetic fibers were used in concrete, and research into new fiber reinforced concrete continues today. Through your words today, on behalf of all participants, I assure that your talk provokes our knowledge on toughness characterization of hybrid fiber reinforced concrete and various tests conducted on it. Once again, I thank our special speaker on the day of the day, Dr. Chella Gifta ma'am, for her presence, and I thank all our participants for attending today's session. Thank you all.
Thank you, madam.
Thank you, sir.
Dr.
Thank you, sir.
Sellagipta, madam,
Thank you,
sparing
sir.
your valuable time and shared your things.
Thank you,
Really,
sir.
really, your informations will motivate the young community of the faculty members to do more innovative research work in the field of fiber reinforced concrete.
Yes, sir. Yes, sir. Surely we can get some research. That's what special thing in FRC. In other composites, getting the results is very difficult, but in FRC, we can surely get some valuable results during the experiment. Thank you, sir. I wish you all the best for your future endeavors. Thank you, sir.
Thank you, ma'am. Thank you. Participant? Yes, ma'am. Yes.
Can I leave? Can I?
Yes, ma'am.
Yes, madam. Yes, madam.
Thank you, ma'am. Participant, your today's attendance link, it is posted in the chat box. Both attendance and feedback link, it is posted in the chat box. Kindly fill it and leave the meeting. Kindly fill the attendance link as well as feedback link.